This is Discover Launch Control at T-minus 2 hours, 14 minutes and counting. Everything continues to be go for the launch of Discover and a Falcon 9 rocket at 6:10 p.m. Dr. Catherine Sullivan is the Undersecretary of Commerce for Oceans and Atmosphere and Administrator of the National Oceanic and Atmospheric Administration, or NOAA. She is the U.S. co-chair of the Group on Earth Observations, which is an intergovernmental body that's building a global Earth observation system of systems to provide environmental intelligence relevant to societal needs. She also was one of the first 6 women selected to join the NASA Astronaut Corps in 1978, and she holds the distinction of being the first American woman to walk in space. Dr. Sullivan flew on 3 space shuttle missions during her 15-year tenure, including the mission that deployed the Hubble Space Telescope. She also served on the National Science Board and as an oceanographer in the U.S. Navy Reserve. She holds a bachelor's degree in earth sciences from the University of California at Santa Cruz and a doctorate in geology. And just a few days ago, she stopped by and recorded a message for us that we would like to play for you now.
Well, NOAA is designated as the operational lead for all sorts of environmental forecasting in the civilian sector. This is our cornerstone mission of providing the environmental intelligence that our government, our citizens, and our corporations need to keep the country humming. Space weather is just one of those examples. We're responsible for fielding the observing systems, Discover being one key element in this case, that provide the reliable observations which, when coupled with models of the Earth's magnetosphere in this case, allow us to make really reliable, actionable predictions of where these events, these natural events, will have impacts that can affect our economy and our society. We work in close partnership with science organizations such as NASA and our partners in the Air Force to put the total picture together of instrumentation, space assets, launch vehicle capability. But at the end of the day, it's NOAA's responsibility to spec out, set requirements for, manage, and fund these systems, and then develop the operational forecasts and provide the data to all the different segments of our society. We expect Discover to make a really significant advance in our operational forecasting. The quality of the data, the timeliness with which we'll receive them, and then coupling that to a model, an advanced model of Earth's magnetosphere, which will come online by the end of the year, should tremendously improve the timeliness and the quality and the regionality and specificity of the forecasts that we can provide about space weather events and their impacts here on Earth. Only an asset such as Discover, placed 1 million miles from Earth out at the L1 point, can give the 15 to 60 minute advanced warning that a blast from the sun of charged particles and embedded magnetic field is headed our way. And when that interacts with the Earth's magnetic field and long conductors on the ground, such as transmission lines and pipelines, may really create some very severe impacts in our infrastructure. Discover will play a really critical role in one of NOAA's big responsibilities for environmental intelligence, and that's providing the space weather forecasts that alert users on Earth, citizens, businesses, governments, alert them to the pending impacts of a major solar storm. We think of Discover as a weather buoy. It sits upstream of the Earth, right on line with the sun, 1 million miles away, and it senses first the blasts of solar wind and embedded magnetic field that are going to potentially wreak some havoc and damage on overhead satellite systems, on pipelines, on transmission lines here on Earth. Discover is a really good example of 3 agencies within the U.S. government coming together like well-fitting pieces of a jigsaw puzzle to make an integrated mission happen. NOAA, as the operational forecasting entity, has the overall responsibility for mission management and technical support. We'll fly the spacecraft once it's out at orbit at the L1 point, and we're responsible for the modeling and the forecast generation and the dissemination of all the data. We turn to NASA to serve as our acquisition and design partner to help procure and refurbish the spacecraft and manage that whole segment of the delivery and preparation of the space segment itself. And NASA also funded the refurbishment of the Earth instruments, which will be on Discover and provide a watchful eye all the time back on Earth. And then the United States Air Force as one of the primary launch service providers in the country. So the Air Force provides the launch. Our NASA colleagues provide the space segment spacecraft design, development, and engineering acumen, so we don't need to replicate that at NOAA. And NOAA takes the umbrella and enveloping responsibility for overall project management and funding support, and then for the execution of what we actually consider the mission, which is everything from when the ones and zeros come back to Earth to where the actionable information reaches society. That in NOAA land, that's the actual mission.
Closures. Copy.
This is Discover Launch Control at T-minus 2 hours, 8 minutes, 28 seconds and counting. Everything continues on track for an on-time liftoff of the Falcon 9 rocket carrying Discover into space. As we get closer to launch, you'll begin to hear some of the communication traffic, and some of the voices that you'll hear include SpaceX Launch Director Ricky Lim, Launch Conductor for SpaceX Ty Morton, and the SpaceX Chief Engineer John Murator. And for Discover, the Spacecraft Mission Director is Bob Smith, Spacecraft Test Director is Tracy Meyer, and the Launch Vehicle Systems Engineer Jonathan Fulford. They are sort of the tip of the spear for teams across the country who are monitoring systems for both the rocket and the Discover spacecraft. Discover, which formerly was known as Triana, originally was conceived in the late 1990s as a NASA Earth science mission that would provide a near continuous view of Earth and measure Earth's albedo. In 2001, Triana was canceled and the satellite went into storage in a clean room monitored by NASA. NOAA funded NASA to remove Discover from storage and test it in 2008, and that same year the Committee on Space Environmental Sensor Mitigation Options, an interagency assessment requested by the White House Office of Science and Technology Policy, determined that Discover was the optimal solution for meeting NOAA and the U.S. Air Force space weather requirements. As we've been saying, NOAA is responsible for the Discover mission, providing program management, spacecraft operation, and distribution of all mission data. NOAA funded NASA to refurbish the spacecraft, to recalibrate the space weather sensors, prepare it for launch, develop the ground systems and operations, and provide technical management of the space segment. Discover is going to succeed NASA's Advanced Composition Explorers, or ACE, role in supporting the solar wind alerts and warnings from NOAA. In 2012, NASA brought the Discover spacecraft out of storage at NASA's Goddard Space Flight Center in Greenbelt, Maryland, where the spacecraft originally was built. NASA inspected all the instruments, tested the mechanisms, provided new electrical components, and conducted environmental tests of the observatory. In addition, NASA funded the refurbishment and recalibration of the two Earth science instruments and is supporting the analysis of their data. The U.S. Air Force is providing the SpaceX Falcon 9 launch vehicle through the launch services contract with SpaceX. So again, an interagency cooperative venture underway and very successful in preparing the spacecraft and the rocket for launch today. Fueling operation is on track. There are no major technical issues underway, and weather is green across the board. Nothing standing in the way at this point of launch on time at 6:10 p.m. Eastern. The NOAA Space Weather Prediction Center, located in Boulder, Colorado, as Dr. Berger was talking about a little while ago, is an integral part of the information chain that helps to alert us of dangerous conditions. And we have a video that tells us more about the Space Weather Center.
Technology. It's the rhythm of our everyday life. We're more dependent on satellite and communication systems than at any other time in history. Disruptions can affect our economy and even our safety. To prepare for the effects of such events and minimize impacts, we need to look outside our atmosphere, some 93 million miles away, at a star we call the Sun. It's our main energy source. It warms the Earth and grows our food. While the Sun and the space between may seem pleasant from our perspective, it's anything but peaceful. At its surface exists a chaotic state of eruptions and radiation. And unlike Vegas, what happens at the Sun doesn't stay at the Sun.
Space weather is essentially emissions from the Sun, radiation, magnetic field that erupts from the solar surface, pumped out into space, sometimes right towards Earth. When it impacts the Earth, it impacts our technology. That's what we call space weather.
These solar events and their effects at Earth can disrupt systems we take for granted, from causing blackouts to the power grid, to delaying offshore drilling operations due to inaccurate GPS data. Interference with communication systems can force air traffic to reroute and impact rescue response and coordination. Outside our atmosphere, solar radiation can harm astronauts and the systems they depend on. The good news is that these eruptions can be detected early. Forecasters at the NOAA Space Weather Prediction Center in Boulder, Colorado, have their eyes on the Sun at all times.
The Space Weather Prediction Center is part of the National Weather Service and is very much like a normal weather forecast office. We're here 24 hours a day, 7 days a week. We're looking at data, we're looking at imagery, we're looking at model outputs. As conditions develop, we put out alerts, warnings, and watches of imminent activity to our customers so they can take action.
In many ways, forecasting space weather is a lot like forecasting hurricanes. Those who rely on space weather forecasts, like electric power grid managers, are informed early on and can begin taking protective action.
When we see an eruption on the Sun, space weather forecasters will issue a watch. And this is much like a hurricane watch. When a hurricane sits offshore of Miami, for example, perhaps 48 hours out, we too can see way in advance that something may be coming towards the Earth.
As the storm moves toward us, it hits a monitoring spacecraft orbiting 1 million miles away from Earth.
It's kind of our buoy sitting out there offshore, and that hurricane about 30, 45 minutes before it makes landfall, we'll get the measurements from the buoy. That's what the spacecraft does for us. That big eruption that left the Sun hits the spacecraft. Now we've got the measurements of exactly what's going to impact us here on Earth, and we issue the warnings to give the power grid a heads up that the storm is now imminent. An interesting element to this whole process is that when the forecasters issue the alert, the power grid receives the alert, takes the necessary actions to protect the grid, and the average citizen never knows anything ever happened.
The number of customers who rely on space weather information continues to grow. As our reliance on technology increases, so will our need for constant monitoring of the Sun.
This is Discover Launch Control at T-minus 1 hour, 59 minutes, 7 seconds, and counting. What they would call a Chamber of Commerce day. Picture perfect for a launch here on the Space Coast in Florida. Cape Canaveral Air Force Station with vibrant sunshine lighting up the Falcon 9 rocket on Space Launch Complex 40, the Discover rocket on top, ready to be lofted into space to begin its journey to return data to Earth to help protect the planet. We would like to welcome Brian Olnick, who's Vice President of Distribution Operations for Florida Power and Light, known here in Florida as FPL. Brian, welcome.
Thank you, Mike.
Glad to have you here. One of the things that we've been talking about today with solar events disrupting our lives on Earth definitely is power, and FPL is a giant here in the state of Florida. How many customers do you serve? Residential, business, etc.
Sure, Mike. Here in Florida, we serve 4.7 million customers. Of that 4.7, about 500,000 of them are commercial, industrial customers, but that really represents about half the population of the state of Florida.
How do you prepare for the onslaught of some kind of a solar event?
Well, first of all, early notification is important, and we receive early notification from federal agencies like NOAA, National Weather Service, and then we take that information and give an early notice to some of our key personnel, and that allows us the opportunity to be able to take any preventive action that could potentially occur.
So what kind of action can you take, and what exactly can happen if we get a solar event? How can it affect the grid?
Well, this kind of event can have an impact on the transmission system and also our communications system. And at Florida Power and Light, we use a lot of our technologies, smart grid technologies as one example, to be able to take all of the data that's coming in from our sensor network and be able to many times take predictive type measures, and that way through all of that information and all of that technology, if there was an unexpected event to occur, we can usually take any kind of proactive measures ahead of time, and if possible, we would reroute the power if needed. Fortunately, here in the state of Florida, because of our geology and even our location and latitude and longitude, these kinds of geomagnetic events aren't quite as impactful in this state of Florida. As a matter of fact, we really haven't had any impact to our system from any of these kind of solar storms.
But it's good that you're ready.
Thank you. Yes.
Well,
always on guard.
Yeah, always on guard. We greatly appreciate it. We certainly rely on your power for everything we do every day.
Thank you. And, the Cape is an important customer of ours, and we're looking forward to providing that continued reliable service.
Very well. All right. Thank you for your time. Thanks for coming
Mike.
by.
Great. Looking forward for a great launch today.
Me too. This is Discover Launch Control at T-minus 1 hour, 52 minutes and counting. You're looking at the Falcon 9 rocket on the launch pad. Venting gaseous oxygen from the second stage as tanking operations proceed on target. Several months ago, both the Falcon 9 first and second stages were transported to the SpaceX rocket development facility in McGregor, Texas for testing, and then they were trucked to SpaceX's hangar at Space Launch Complex 40 here at Cape Canaveral Air Force Station in Florida. The stages were integrated, and then the Discover payload was put inside of the fairing at the Astrotech facility in Titusville nearby and brought over and integrated with the Falcon 9 rocket. The final major pre-flight test was a static fire held on Saturday, January 31st. All 9 of the Falcon 9's first stage engines were lit for a few seconds while the vehicle was held firmly in place. Everything went well. And earlier today, the Falcon 9 and Discover were elevated to their vertical position for launch. Fueling continues on schedule with the payload fairing and Discover inside. The Falcon 9 is 224 feet tall and 12 feet in diameter. At the time of launch, the 9 first stage engines will generate 1.3 million pounds of thrust at liftoff, rising to nearly 1.5 million pounds as it climbs through the atmosphere. The payload fairing itself is 43 feet long and 17 feet in diameter. Very impressive sight, and it will be even more impressive when it lifts off 2 minutes after local sunset, with the Earth being darker than the sky. So we expect that shortly after liftoff, as the Falcon 9 begins its climb from the launch pad, that the sun from the west will illuminate the plume and the rocket, and it should be a very spectacular sight. Again, everything is on track for launch. T-minus 1 hour, 49 minutes, 50 seconds and counting. This is Discover Launch Control.
FTS, LC on countdown net. I want to verify that you'll be ready for FTS checks in 1 hour and 45 minutes.
This is Falcon and Discover Launch Control. 1 hour, 47 minutes away from liftoff. And we are pleased at this time to be joined by Tim Drum. Tim is a meteorologist with Florida Power and Light.
Correct.
And we wanted to talk with you. I think it's a great role. It's interesting, because I personally had not contemplated that that FPL had meteorologists, but it makes perfect sense.
It does, and it's amazing how many different areas of the company that weather plays a significant role. Lightning impacts our operations. Wind gusts inside thunderstorms, wind gusts outside of thunderstorms, flooding, tropical cyclones, they all impact the operations of Florida Power and Light, and we're constantly monitoring that to try to get the most advanced warning that we can of any impending adverse weather.
So here in Florida, you're dealing with severe thunderstorms and tornadoes and the occasional hurricane.
We're dealing with just about everything except winter weather here for the most part. Absolutely. Right. Lightning is a major impact for us. Day-to-day lightning events, day-to-day thunderstorm activity, every day practically from May through, let's say September, there are thunderstorms in the peninsula that impact our operations. And it's all about getting the right number of people in the right place at the right time.
So that's the benefit of an accurate weather forecast?
Absolutely, to get the electricity back on as soon as we can and to get it back on as efficiently as we can.
Now, do you receive space weather forecasts and alerts?
We do. We receive alerts from a number of federal agencies, including the National Weather Service, the local offices, as well as Space Prediction Center, as well as NOAA. We have very good relationships with the National Hurricane Center, and as well as the local National Weather Service forecast offices, and we're constantly preparing for this. We have drills all year long that help us prepare for adverse weather.
So these space weather alerts help you just the same as the Earth weather alerts do?
They absolutely do. Just like Earth weather, the more lead time we can get to the impending weather, then the more we can be prepared.
So I also let you get back to it, but understand that you have a history of doing meteorology on television.
I did for a while, yes I did. I started out though at an electric utility company in North Carolina and started doing some television on the side. Did that on the side, and I had a career choice to make, so I decided to get in television for about a decade, and then I really decided I wanted to get back into the real weather and the science side, so I landed at Florida Power and Light.
Well, we're glad you're there, and we really appreciate the hard work that you do in keeping the grid online and keeping us working every day.
We are struggling and striving to do the best we can every day, Mike, and as I understand, the weather is a go for launch.
Weather is go for launch, yes.
All right, very good.
Thank you very much, Tim.
Thank you, Mike.
.160.
LC's ready. RC's ready.
Copy.
Yes, OSM, RCO, and MIFO proceed FTS checks on the ROPSnet.
This is Discover Launch Control at T-minus 1 hour, 42 minutes and counting. And since we were just talking weather with Tim from Florida Power and Light, and since weather is a big issue and a primary focus, space weather for the Discover mission, just wanted to reiterate that everything here in Florida looks good in terms of the launch weather forecast. An hour away from launch, or in about 41 minutes, Launch Weather Officer Mike McAleenan will brief the team again, and we'll get a chance to listen to his weather forecast. But it's a beautiful day in Central Florida and along the Space Coast with plenty of sunshine. At the time of launch, the temperature is expected to be 68 degrees Fahrenheit, visibility 7 miles, no precipitation or any other weather elements that would be an impact. They're calling for a few cumulus clouds from 3,000 to 5,000 feet and altocumulus clouds scattered from 9,000 to 12,000 feet. Nothing that would stand in the way of launch. The forecast is holding in at 90% go. It's an instantaneous launch window, which means that we need to launch on the 2nd in order to launch today. 6:10 p.m. and 12 seconds is the official launch time. Everything is green in the forecast for weather, and we are not expecting weather to be an issue today. In fact, it is a spectacular day along the Space Coast. We're looking live at a shot of the Falcon 9 rocket. It's at Space Launch Complex 40 at Cape Canaveral Air Force Station. SpaceX is flying this for the United States Air Force in conjunction with NOAA and NASA. And this Falcon 9 rocket is going to send a spacecraft way far away to 1,241,000 by 187 kilometer orbit. And the launch inclination off the launch pad is 37 degrees. So slightly east of north. And if all goes as planned, with the first stage burn and then 2 burns from the second stage engine, Discover will be deployed into space about 35 minutes after liftoff. Once again, everything is on schedule. There are no major technical issues and weather is green. Liftoff targeted for 6:10 and 12 seconds p.m. Eastern Time. This is Discover Launch Control. This is Discover Launch Control at T-minus 1 hour, 34 minutes, 33 seconds and counting. As we've been saying, the space weather incidents can affect our lives in many, many ways. The global positioning satellites guide many of us every day as we go throughout our lives, and that service can be disrupted by a solar event. We'd like to play a tape now for you that explains a little bit more about that.
Space weather affects technologies. As conditions develop, we put out alerts, warnings, and watches to our customers so they can take action.
GPS has changed society. Most people don't realize how remarkable and how many different applications there are.
The GPS has become an integral part, not just of our daily lives as far as cell phones and guidance for our cars and mapping, but the whole system in agriculture is really relying heavily on high accuracy GPS.
So they're using GPS to plant those seeds with centimeter accuracy, and then they can come behind it and irrigate and fertilize right where that seed is with that 1 centimeter accuracy.
The GPS creates a line for the operator that he can steer along, or you go to another level and the operator doesn't steer anymore and the tractor has an automatic steering system on it, much like a cruise control on a car, except for when I push the button it doesn't drive a set speed. When I push a button it stays on a predefined line.
You don't even need lights. You can do it at nighttime. You program your GPS and it's driving that tractor for you. So it's huge, and it's changing the way that the farmers farm the fields.
6 or 7 days out.
There's an interest in GPS applications from the space weather side because when the sun is eruptive, it causes GPS to falter, and in some cases it doesn't work at all.
Productivity may suffer to a certain degree in that there's no way that I as a human being can steer as good 8 hours a day as a GPS system's going to do. It's going to be the same all day long. Some of the other application technologies, those are going to be gone. We're not going to have the ability to do good section control on sprayers and planters and fertilizer applicators without GPS.
We see a huge growing customer base in so many different industries, so many different sectors now relying on GPS and high precision GPS. It's all big customers for us.
We're back live at Space Launch Complex 40 on Cape Canaveral Air Force Station in Florida, where everything is proceeding on schedule for the liftoff of Discover atop the Falcon 9 rocket. Fueling operations have gone well. Earlier, the first motion check was completed, and checkouts of the flight termination system also were completed successfully. Very little traffic on the communication circuits, as no teams are working any major issues. But as we get closer to liftoff, once again, some of the voices that you may hear from SpaceX Launch Director Ricky Lim, Launch Conductor Ty Morton, and Chief Engineer John Murator. And for the Discover spacecraft, Spacecraft Mission Director Bob Smith, Spacecraft Test Director Tracy Meyer, and Launch Vehicle Systems Engineer Jonathan Fulford. Just over 1 hour and 30 minutes away from the planned launch of Discover. This is Discover Launch Control. This is Discover Launch Control at T-minus 1 hour, 27 minutes, 56 seconds, and counting. Discover Spacecraft Test Director Tracy Meyer just polled his team monitoring all the Discover spacecraft systems and reported to Spacecraft Mission Director Bob Smith that everything is go to continue with the count. Again, there are no major technical issues on either the spacecraft or the Falcon 9 rocket. Weather remains green and forecast 90% go for the time of launch. Discover is going to make unique space measurements from the first Sun-Earth Lagrange point, or L1, which is on the direct line between Earth and the Sun, located about 930,000 miles sunward from Earth, and it's a neutral gravity point between the Earth and the Sun. Discover will be orbiting this point in a 6-month orbit with a spacecraft Earth-Sun angle varying between 4 and 15 degrees. The L1 vantage point offers a continuous view of the entire sunlit half of the Earth in a snapshot, as opposed to the other Earth-observing satellites, which are situated closer to Earth that capture an image strip that is later stitched together. So the entire planet, the sunlit half, in one snapshot. The NASA Earth Polychromatic Imaging Camera, or EPIC, EPIC, instrument provides spectral images of the entire sunlit face of Earth as viewed from that orbit around L1. EPIC is able to view the entire sunlit Earth from sunrise to sunset, and its observations will provide a unique perspective and will be used in science applications to measure ozone and aerosol amounts, cloud height, vegetation properties, and ultraviolet reflectivity of Earth. The EPIC data will be used by NASA for a number of Earth science developments, including dust and volcanic ash maps of the entire Earth. EPIC is will be making images of the sunlit face of the Earth in 10 narrowband spectral channels. As part of the EPIC data processing, a full disk true color Earth image will be produced about every 2 hours. And this information will be publicly available through the NASA Langley Research Center in Hampton, Virginia, about 24 hours after the images are acquired. The other NASA instrument, the National Institute of Standards and Technology Advanced Radiometer, or NISTAR, is a cavity radiometer designed to measure the reflected and emitted energy from the Earth, the entire sunlit face of the Earth. This measurement is intended to improve understanding of the effects of changes in Earth's radiation budget that are caused by human activities and natural phenomena. The information from NISTAR can be used for climate science applications, and it will measure the amount of reflected sunlight and the thermal radiation of Earth in the direction towards the Sun. These quantities are viewed as being key ingredients of the current climate models. So this is a day that many people from within NASA, NOAA, and the Air Force, and SpaceX are all looking forward to. We're an hour and 24 minutes, 18 seconds from launch of Discover. This is Discover Launch Control. This is Discover Launch Control at T-minus 1 hour, 20 minutes and counting. Everything remains on track for the liftoff of the Falcon 9 rocket carrying Discover into space at 6:10 and 12 seconds p.m. Eastern Time. Discover will help with our prediction of space weather incidents in the future. And as we've been talking about, these space weather incidents can affect our lives in many ways. We all rely on cellular phones and other communication technologies every day, and these services can be disrupted by a solar event. And here with some more information on that, we have a tape package that we would like to play for you.
Space weather affects technologies. As conditions develop, we put out alerts, warnings, and watches to our customers so they can take action.
There's different types of impacts on communication systems. In the HF, we call it high frequency, which is that band of communications, 3 to 30 megahertz. But it's a very important band of radio communication because it's used widespread. It's used, for example, by the airlines.
HF radio is most commonly used for position reporting when you're going across the ocean, airspace, which is devoid of radar, and ATC can't see you, so it's up to you to report your position and your altitude and your speed.
HF works great most of the time, except during a big flare. And during a big flare, that HF communication capability could be gone within a minute or two. So as soon as we see something happening in there or we see a flare, it's one of the first things we do is alert the aviation community, hey, big flare, HF's going to be impacted.
Once we know that there's an event going on, then the aviation industry and the airlines can react to that. They can alter their routes over the poles. They can lower the altitudes that they're flying at, or maybe decide not to fly at all in the interest of the passenger safety.
So that's just one example of how HF is used, but the emergency response community will use it a lot too. It's one of their primary backups.
When you've lost connectivity between certain government agencies, it gives you that long-range coverage to talk from out of state to federal governments or from the FEMA locations to the state emergency operations centers.
So if you've got a big hurricane impact in the coastline, whatever big city, we've got the cell towers down and whatnot, we've got emergency communication folks in there. Those folks are very familiar with space weather and how it impacts their systems.
Here in recent years, it was used during Katrina when we had a lot of communications outages down there. It was also used during Hurricane Ike. There was an outage of the telephone circuits with the Texas State Emergency Office, so it was used in both of those situations.
So when we talk about backup, especially for the airlines, typically they'll have SATCOM, so it'll be satellite communication.
The satellite technology that emergency responders use could be GPSs, could be satellite phones, satellite data terminals.
Space weather events can impact SATCOMs. The impact can range from a nuisance to loss of a spacecraft. So we will give them the heads up. If we have space weather events, flares, whatnot, they need to know what's impacting their systems. Situational awareness is key. Time is of essence to these folks. Again, it's life and death.
Back live at Cape Canaveral Air Force Station in Florida, Space Launch Complex 40, where the SpaceX Falcon 9 rocket is poised and ready for launch with the Discover payload safely tucked into the payload fairing at the top of the rocket. Fueling operations have gone well. Every element in the checklist has gone well so far. Teams are not working any major issues, and as you can see from that view, it's just a picture-perfect day in sunny Florida. As Launch Weather Officer Mike McAleenan mentioned at the L-1 pre-launch news conference yesterday, one of the great things about living in Florida is that winter ends at 10 a.m. every day. And temperatures are right around 70 degrees right now. At liftoff, the temperature is expected to be 68 degrees. clear skies, just a very narrow band of clouds scattered. Nothing standing in the way of an on-time liftoff of the Falcon 9 rocket with Discover at 6:10 p.m. This is Discover Launch Control. This is Discover Launch Control at T-minus 1 hour, 9 minutes, 57 seconds and counting. Counting down to the planned launch of a Falcon 9 rocket with the Discover payload at 6:10 and 12 seconds p.m. Eastern Time. We'll be standing by for a weather briefing in about 6 minutes from Launch Weather Officer Mike McAleenan. Or excuse me, in about 10 minutes. 1 hour away from launch. And with the liftoff of the Deep Space Climate Observatory, or DSCOVR, the U.S. will extend its ability to give accurate warnings of solar activity that potentially could wreak havoc throughout society and, frankly, upset the economy as well. DSCOVR is a refrigerator-sized satellite, and it's a partnership between NOAA, NASA, and the U.S. Air Force. It will orbit the Sun at the L1 Lagrange point, a stable point in space where the gravitational forces of Earth and the Sun are in equilibrium, and it's about 1 million miles away from Earth toward the Sun. From this location at L1, DSCOVR sensors can detect solar storms before their impacts reach Earth, which is very important. The satellite also will host NASA-funded secondary sensors for Earth and space science observations. NOAA is managing the DSCOVR mission, giving advanced warning of approaching solar storms with the potential to cripple electrical grids, disrupt communication systems, throw off the GPS navigation system, and reroute air traffic, affect satellite operations, and endanger human spaceflight. According to a National Research Council report, damages from the most extreme solar storms could range between $1 and $2 trillion within the first year, and 4 to 10 years for a full recovery. So this is a very important spacecraft. Currently, NASA's Advanced Composition Explorer, or ACE, which was launched in 1997, is our only spacecraft that provides solar storm data to the NOAA Space Weather Prediction Center in Boulder, Colorado, for operational short-term warnings of solar storms. ACE is also stationed at the L1 point, giving forecasters data on approaching solar events. However, ACE is operating more than 10 years beyond its design life. DSCOVR observations typically will enable the Space Weather Prediction Center to provide 15 to 60-minute warning lead times before the impact of a solar storm hits Earth, which is similar to what ACE currently provides. The instruments on DSCOVR will improve upon what we have on ACE, however, as they will continue to operate even during severe space weather storms. The DSCOVR data will also be used to drive the next generation of space weather models, allowing forecasters to specify where on Earth the storm conditions will be at their worst. You'll recall that DSCOVR was formerly known as Triana, initially planned in the late 1990s as a NASA Earth science mission that would image Earth in 10 spectral bands and measure how much energy was being reflected and emitted from Earth. 7 years later, NOAA and the Air Force worked with NASA to remove DSCOVR from storage so that the spacecraft and its instruments could be tested to verify their flight readiness. NOAA funded NASA to refurbish the DSCOVR satellite and instruments. The U.S. Air Force is funding and overseeing the launch of the spacecraft on the SpaceX Falcon 9. And in the fall of 2013, after a period of testing and other technical inspections, NOAA and NASA confirmed DSCOVR could meet the requirements within its planned life cycle cost and projected schedule. Then the DSCOVR program received full funding with the fiscal year 2014 appropriations. NOAA's Satellite Operations Facility in Suitland, Maryland, will manage DSCOVR operations, and the Space Weather Prediction Center in Boulder, Colorado, will process and distribute its data to users within the United States and around the world. So after all of that, it's come to this. We are here today at Cape Canaveral Air Force Station in Florida, looking at Space Launch Complex 40, where the DSCOVR spacecraft is ready to begin its life with a liftoff at 6:10 and 12 seconds p.m. Eastern Standard Time. This is Discover Launch Control. This is Discover Launch Control at T-minus 1 hour, 21 minutes and counting. We'll be standing by in just a moment for a weather briefing from 45th Space Wing Launch Weather Officer Mike McAleenan, who is going to brief the team on the current weather conditions and those forecast for launch at 6:10 p.m. Standing by now for the weather briefing.
This is the LWO with the L-1 hour range weather briefing. Looking at your video screen, IPTV channel 7, you can see an IR satellite picture showing clear skies over the Florida Peninsula and the southeast U.S. There's also a pretty broad swath of cloudiness from western Cuba up through the central Gulf of Mexico, and that area will be migrating towards the peninsula overnight and into tomorrow morning. You can also see in the Tennessee Valley a cold front digging into the southeast U.S. That's going to provide some extra cloud cover and instability as it approaches northern Florida tomorrow. However, for today's mission, you can see again, the peninsula of Florida is just about cloud-free along the Space Coast, and the cumulus clouds in the central part of the peninsula are eroding rapidly. We expect no chances of cloud cover over the spaceport, and viewing for the launch should be spectacular. Looking at the upper level conditions, earlier we had some fairly strong shear, and we're seeing since 12Z in the last 8 hours or so, those winds drop off fairly significantly, 10 to 15 knots in the upper levels, and increase 10 to 15 knots in the lower levels, creating an atmosphere of not a whole lot of shear and pretty good upper level capabilities. Looking at the wind speeds a little bit lower at the tower, you can see they're fairly benign at about 8 peak to 10 knots, and expected to remain so through the remainder of the count. The direction has been out of the southeast with the sea breeze once we started that about noon or so, and we expect it to continue out of the southeast through the remainder of the window. Looking at solar weather, the sun is also behaving, and you can see the proton flux, electron flux, and planetary K-index are all well within solar constraints. So right now, we are go on all range weather safety and Falcon 9 weather commit criteria, and expected to remain so for the next hour. Currently, the forecast has been upgraded to 0% probability of violation, and no longer a concern for the cumulus cloud rule. However, we are still seeing a bit of that cloud cover just off to the west for scattered conditions, but unrestricted visibility. Again, it should be great launch viewing. The recovery area also looks nice, 2 to 3 foot seas, and just a little bit of low cloud cover, and so it looks like a good chance for a landing opportunity for the automated drone vessel. If we were to delay 24 hours into tomorrow evening, we see that area of cloudiness in the Gulf of Mexico and that front will make its way into the Florida Peninsula, causing a significant increase in cloud cover and light rain developing by mid-morning tomorrow. Winds will switch around ahead of that front southwesterly, pick up speed a little bit, and so a 60% chance of violation, with primary concern being the thick cloud layer. So right now we're looking very good for launch, and that's all I have pending your questions.
No questions, thank you.
Okay,
So as you heard, weather is totally cooperating. Mike McAleenan has changed his forecast to 100% go. No chance for any weather launch commit criteria violations, unrestricted visibility, no cumulus clouds over the launch site, a temperature of 69 degrees at the time of liftoff, and as Mike McAleenan said, spectacular view for launch. We're 56 minutes away from the liftoff of Discover atop the Falcon 9 rocket. This is Discover Launch Control. This is Discover Launch Control at T-minus 48 minutes, 57 seconds and counting. Everything is proceeding on track. A beautiful weather forecast for the planned liftoff. You can see liquid oxygen, or excuse me, gaseous oxygen being vented from the first and second stages of the Falcon 9 rocket. Discover, encased in the payload fairing at the top of the rocket, is why we're all here today. And joining us now to talk even more about it, I'd like to welcome Steve Clark, the director of the NASA Joint Agency Satellite Division under the Science Mission Directorate at NASA headquarters in Washington.
Good evening,
Hello,
Mike.
Steve. How are you?
Great. How are you?
I'm doing great. So we're all excited. We're getting very close to launch time. Can you tell us a little bit more about what your group, the JASD, right? Is that how you would pronounce it?
That's what we call it for short. That's correct.
And how how you interacted with getting Discover where it is today?
Certainly. Well, my division was set up at NASA headquarters in 2010, and we work closely with our NOAA partners. They provide the requirements for all of their weather forecasting spacecraft and provide the funding. And my office manages the acquisition of those satellites that will meet those requirements. We build the spacecraft, launch the spacecraft, and then perform on-orbit checkouts, make sure all the systems are good. And once we've done that, we turn the keys over to NOAA to operate the spacecraft, and then the responsibility is with NOAA.
What other missions are you working with NOAA on?
Well, we have a broad portfolio, actually, Mike. Discover is the first one that we have JASD have managed. Later this year, we have Jason 3, which is an ocean altimetry mission. And in fact, it's the third of a series of the Jason spacecraft. I actually worked the Jason 1 mission earlier in my career, so this is a nice circle back to that. And we'll be launching off of Falcon 9 out of the Vandenberg Air Force Base. Then we also have the DSCOVR program, which are the geosynchronous weather forecasting satellites. There's a new series of those satellites being built, starting with DSCOVR, 4 of them to be exact, and it's being tested right now at Lockheed Martin in Denver, and we plan on launching that in March of next year on an Atlas V from here. And we also have the Joint Polar Satellite System. And by its name, as you can tell, it's going to be a polar orbiting spacecraft versus a geosynchronous satellite, which will basically be looking at the same spot on the Earth. The Joint Polar Satellite System is the follow-on to SUMI NPP, which is on orbit now and operating. This will be a series of JPSS-1, which will be launching in 2017. And we just now have received proposals on JPSS-2 and some potential follow-on. So this is a long-term series of spacecraft with the instruments that provide the critical weather forecasting data for NOAA. And so we're pretty excited about this partnership. It's been working well.
Now on Discover, the spacecraft that we're talking about today, NASA has 2 instruments. And can you tell us a little bit about what they will be bringing back to Earth?
Certainly. One is the Earth polychromatic imager, and this is a camera that was part of the Triana instrument suite. And this camera will be looking at the Earth at its vantage point, about 1 million miles from Earth, between the Sun and Earth, looking at the lit side of Earth at all times. And it'll be taking not only pictures that will be downloaded once per day over the Wallops ground station, and then those images will be placed onto a public website the next day. It also is taking valuable Earth science data, and it'll be looking at the atmosphere, looking at aerosol contents, the ozone layers, looking at the effects of volcanic ash, and so forth like that. So that's valuable Earth science data that will be provided to the user communities out there. And then the second instrument is called NISTAR, and it's an advanced radiometer. And a simple way to put that, I think, is it's going to look at how much radiation is emitted from the Earth naturally from heating, but also the reflective radiation with the sun hitting the Earth's atmosphere, and it'll actually calculate a balance of that. And so that's a critical part of Earth science research to the user community as well.
That is very exciting.
Oh, it is. It's great to be at this point here. So we're all pretty excited about getting this mission off.
Well, we are too, and we're just over 40 minutes away from the planned liftoff. So we'll let you get back to work. You're working here at Cape Canaveral Air Force Station in the Hangar AE Mission Director Center with a lot of your colleagues. So we really appreciate you taking some time to spend with us.
Oh, my pleasure.
All right. Thank you.
Go Discover and go Falcon 9.
You bet. This is Discover Launch Control at T-minus 38 minutes, 18 seconds and counting. Standing by for the launch today of the Falcon 9 rocket, carrying Discover into space. Again, Discover will help with the forecasting of space weather, which can disrupt many services that we're accustomed to having access to around the clock, 7 days a week. As we heard earlier, it can affect global positioning, satellite system, communications, and it also can affect power. And we'd like to play a tape for you at this time that explains a little bit more.
Space weather affects technologies. As conditions develop, we put out alerts, warnings, and watches to our customers so they can take action.
The Space Weather Prediction Center has had a long-standing relationship with the power industry, so they've been aware that solar storms, the geomagnetic storm piece of that, can affect the operation of systems and induce extra currents and loads on those systems that can either trip those systems offline or in the worst of cases, cause damage. That relationship goes back for several decades. In fact, a big incident in 1989 where part of Quebec was tripped offline that affected something like 6 million customers for about 9 hours. I think that really raised the awareness in the power industries.
When we get the alert, we watch the grid and start looking for issues. Are we seeing a decline in voltage? Are we seeing equipment failures? And we readjust the system to try to mitigate those problems, try to keep the lights on and keep it from going out.
So we're averaging about 500, 550 kilometers per second.
If we didn't have this early warning, we wouldn't see it until our sensor saw it. Getting more information quicker and faster before the storm hits, not during the storm, is a big improvement.
In the long term, I think what we need and what we're moving toward, the U.S. as a whole, is better modeling, fully understanding this phenomenon, understanding how it would impact specific systems.
Rather than actually experiencing the storm, we can simulate storms in our software and see what the impact is. We try to get ahead of it. We always plan that if there's an outage, how can we keep the lights on? What's the best process to prevent it?
In the end, 5-10 years from now, there's going to be a whole mix of operational procedures driven by what we do on prediction and warning. And then there also will probably be some level of hardware controls to ensure the reliability of the grid.
We are 35 minutes, 10 seconds away from the planned launch of Discover, and we're getting close to the final stages of the countdown. So far today, the fueling operation has gone well. All items in the checklist have been completed. Weather is 100% go, fully cooperating. We'll have a terminal countdown poll coming up at T-minus 25 minutes, and then we'll get close to some of the final preparations that will be required, including powering up the Discover spacecraft. Polls will be conducted throughout the final minutes of the countdown. And at 10 minutes away from launch, the terminal countdown will begin. About 2.5 minutes away, SpaceX launch director Ricky Lim, after consulting with the Discover team, would give a final go for launch. At T-minus 2 minutes, the Air Force Range Control Officer confirms that the eastern range is go. You'll hear the call out range green. About a minute before launch, the pad's water deluge system, dubbed Niagara, will be activated. The 9 Merlin engines of the first stage will be ignited at T-minus 3 seconds, and then at T-minus 0, the Falcon 9 will lift off. We're at 33 minutes, 16 seconds, and counting. This is Discover Launch Control. T-minus 30 minutes and counting. Everything is on track for an on-time liftoff of Discover atop of Falcon 9 at 6:10 and 12 seconds p.m. Eastern Time. Polls are underway. Engineers in the NOAA Satellite Operations Facility over other engineers in the NOAA Satellite Operations Facility and Discover Systems engineers in Hangar AE here at Cape Canaveral Air Force Station are reporting their status to Spacecraft Test Director Tracy Meyer, who will report their status to the Spacecraft Mission Director Bob Smith. On the SpaceX side, Launch Director Ricky Lim, Launch Conductor Ty Morton, and Chief Engineer John Murator will be conducting polls as well. T-minus 28 minutes and counting.
OSM.
That's OSM.
Can you verify flight blocks are established?
They are established.
T-minus 27 minutes and counting. T-minus 25 minutes and counting for the launch of the DSCOVR spacecraft atop a Falcon 9 rocket from Space Launch Complex 40 at Cape Canaveral Air Force Station in Florida. Weather remains 100% go. Polls are underway for both the spacecraft systems and the Falcon 9 rocket. About 4.5 minutes away from power up of the DSCOVR spacecraft for launch. T-minus 23 minutes and counting. This is a complex operation, launching the Falcon 9 rocket, which is a joint venture of NOAA, NASA, and the U.S. Air Force. The Air Force also controls the Eastern Range assets, which track and follow the launch vehicle as it lifts off from the pad. The range also provides the weather forecast, and today we are blessed with a wonderful weather forecast. Blue skies, sunshine, 100% go weather. Launch remains on target for 6:10 p.m. and 12 seconds Eastern Standard Time. Managers overseeing the spacecraft in the Mission Director Center at Hangar AE on Cape Canaveral Air Force Station, near the launch pad, where the Falcon 9 rocket stands ready to fly. Coming up to T-minus 21 minutes, 21 minutes and counting. T-minus 20 minutes and counting. About 10 minutes away from the terminal countdown, which begins at T-minus 10 minutes, at which point all systems will be autonomous. Falcon 9 rocket is fully fueled with RP-1, a rocket-grade kerosene, as the fuel, and liquid oxygen. You can see the gaseous oxygen venting overboard from the first and second stages of the rocket. This is an expected condition as the oxygen continues to be topped off in the tanks. It's a beautiful day for a launch in Florida. T-minus 19 minutes. T-minus 18 minutes and counting. Liftoff today is technically 2 minutes after the official sunset, which occurs at 6:08 p.m. T-minus 17 minutes and counting, and a number of polls are underway in back rooms assessing everyone's readiness for the terminal count. Just under 16 minutes away from the planned liftoff of the Falcon 9 rocket, launching DSCOVR into space. T-minus 15 minutes. T-minus 14 minutes and counting. We'll be standing by for the official poll coming up momentarily. The launch conductor will conduct his terminal countdown poll, expected at T-minus 13 minutes. Coming up on T-minus 13 minutes and counting.
All stations, verify ready to go into terminal count. FTS. Prop.
Prop go.
AVI. GNC.
GNC go.
Ground.
Ground is go.
BC.
BC go.
GC.
GC is go.
RC. OSM.
OSM go.
Rock. Rock. CE.
CE is go to proceed to T-2, but no further until resolution of the AVI issue.
MD. AVI. AVI is go. Rock. Rock on countdown net.
Rock on countdown net.
Verify go into terminal count.
Go.
MD.
D is confers with going to the 2-minute point.
Copy. LD verify go to initiate terminal count.
This is LD. You have a go for terminal count, and we will hold at pending these open items.
Copy. BC, start the terminal count auto sequence set to start at T-minus 10.
Copy.
SpaceX launch
if a
conductor.
Hold is called from this point, terminal count auto sequence will be aborted. Indicate an abort or hold condition by saying hold, hold, hold on the primary countdown net. In this event, the VC will immediately abort the auto sequence. The VC shall not abort the auto sequence after T-minus 10 seconds. Operators shall not call a hold after T-minus 10 seconds. If a hold is called, all operators proceed to terminal count abort steps, section 10.6.
Launch conductor Ty Morton completing his poll and reporting to launch director Ricky Lim. The plan at this point is to count down to the T-minus 2-minute mark and hold unless they are able to clear an AVI issue.
Attention all personnel by to pick up the count. Counting on. Three, 2, 1, mark. Counts auto started.
12 count has started.
Fine fire X.
Standing by.
Standing by.
RC start the tracking video recorders. OSM, verify launch. Set switch flight.
We're in flight.
Starting in 1D chill.
RC, can you verify the tracking camera?
Started. Ground TTAD system setting up.
This is Discover launch control at T-minus 9 minutes, 3 seconds and counting. The teams are trying to work through two issues, one with a first stage transmitter on the Falcon 9 rocket and the second with the range radar. And they're working to try to clear these issues before we reach the T-minus 2-minute point. T-minus 8 minutes, 29 seconds and counting, and we'll be standing by for Discover to go to internal power at T-minus 8 minutes.
ACS closing out.
T-minus 7 minutes, 28 seconds and counting. Again, the teams are working through two issues. One on the first stage of the Falcon 9 rocket, involving a transmitter, and the other a range radar issue.
Stage 1 heaters closing out.
Minus 7 minutes.
Stage 2 heaters closing out.
T-minus 6 minutes,
Falcon
30 seconds and counting.
Power.
The Falcon
Ground
9 rocket
system
switching to internal power.
Minus 6 minutes.
Stage 1 and Stage 2 pressing up for strong back retract.
Preparing for the strong back to retract away from the Falcon 9 rocket. 5 minutes,
Cradle
43 seconds away from launch. First motion is detected of the strong back.
Final M1D fuel bleed started.
5 minutes, 19 seconds away from launch. Standing by for a go, no-go poll. And we're counting down to T-minus 2 minutes to find out whether these issues have been resolved.
5 minutes.
Once again, this is an instantaneous launch window. If we are unable to launch at exactly 6, 10, and 12 seconds, then we will not launch today. 4 minutes, 45 seconds.
Starting MVAC TVC motion.
And you can see the strong back moving away from the Falcon 9 rocket. This will take about a minute for it to reach the point where it's fully retracted. T-minus 4 minutes and counting. T-minus 3 minutes, 30 seconds and counting. The strong back is completely retracted. Standing by for the flight termination system to go on internal power.
FTS. FTS is armed.
Flight termination system is armed.
MD verify go for launch.
D is no-go for launch.
Copy.
Mission Director is no-go for launch. T-minus 2 minutes, 30 seconds and counting.
Hold. It's a MIFCO with a hold for a loss of track.
Terminal count abort.
Copy. Clock stopped.
OSM ready to safe FTS.
Ready to safe the FTS.
Copy.
VC verified terminal count has aborted, and that terminal count abort has started.
Terminal count abort has started.
CE set warning space, terminal count abort.
Warning space, terminal count abort.
CVC stand by on fire X.
Standing by.
Standing by.
OSM verify ready to safe FTS and report.
Stand by. Verify ready to safe the FTS. OSM is ready to safe the FTS.
Copy.
GC prop AVI and LC ready for strong back raise. Verify the cradle arms are fully open and clear the rocket.
Props ready.
Cradle arms are open. GC scope.
AVI go for strong back raise.
At T-minus 2 minutes, 26 seconds.
OSM set launch able to inhibit.
The MIFCO officer from the Eastern Range called a hold because of a tracking issue. And with the instantaneous launch window, we are scrubbed for today. The strong back is being put back into place.
PC verified stage 1. Stage 2 locks and RP interfaces are vented.
Verified.
Safe per step 60.8.
Verified.
Verified TV.
Verified.
PC verified TTID. Per step 60.
And work.
This is Discovery Launch Control.
We're in safe state. Brake wires are disarmed. FTS is on external power. FTS is state safe.
Copy.
Everyone is safely backing out of the launch configuration. All systems are safe. Power is being removed from the spacecraft. The strong back is being put back into position. Recapping once again, at about 2 minutes and 26 seconds away from the planned launch at 6:10 p.m., the MIFCO reported a hold, citing a range track issue, an issue with the system to track the rocket. We'll stand by for further details, but once again, launch is officially scrubbed for today, and the teams will assess the situation and determine when the next launch opportunity will be. The next possible opportunity to launch would be tomorrow, Monday, February 9th. Liftoff time would be 6:07 and 49 seconds p.m. Eastern Time. There are launch opportunities on Monday, Tuesday, and Wednesday before we would have to stand down for several days and pick up again on February 20th. Once again, the teams are assessing the situation, and it may take some time. What we do know at this point is that it will not be possible to launch today. The Falcon 9 rocket and the DSCOVR spacecraft are in a safe condition, and we'll stand by to find out more information. If a decision is made that we will be scrubbing for 24 hours, then tomorrow, Monday, NASA television coverage would begin at 5 p.m. Eastern for a launch at 6:07 and 49 seconds p.m. Eastern. Again, no firm decision has been made yet, but should this be a 24-hour scrub, we will be on the air at 5 p.m. on NASA television tomorrow. This is DSCOVR Launch Control. Once again, launch today has been scrubbed, and teams are assessing what it will take to come back and try another launch attempt. The preliminary decision is that teams will set up for a 24-hour scrub, which would mean that launch would be tentatively planned for Monday, February 9th at 6:07 and 49 seconds p.m. Eastern Time, with NASA television coverage beginning at 5 p.m. Meanwhile, as they work toward that, teams from
Prop and LC, are you ready to
SpaceX, DSCOVR, and the U.S. Air Force and NOAA will assess the situation and make a final determination. But again, we are in a posture of setting up, at least preliminarily, for a 24-hour scrub and a launch attempt on Monday at 6:07:49 p.m. Eastern Time. NASA television does not plan to carry any kind of a news conference this evening. And again, we are preliminarily setting up for a 24-hour turnaround for a launch Monday at 6:07:49 p.m. Eastern Time.
Attention all on countdown net. Vehicle is now safe. Please by while data path forward is determined. Ground software count on it.
Ground software and count.
Verify data hourly roll.
Hourly roller.
Copy. OSM LC count on it.
This is OSM.
We established roadblocks at the BDA.
In work.
This is DSCOVR Launch Control. Everyone is in the process of backing out of today's launch attempt. As they always say, spaceflight is hard. There are a lot of things that have to come together at one time for it to be successful, and today just wasn't quite that day. There are plenty of launch opportunities ahead. A preliminary decision has been made to attempt launch tomorrow, Monday, February 9th, at 6:07:49 p.m. Eastern Time. And overnight and tomorrow morning, teams will assess their data and determine whether they, in fact, will be ready to attempt that. But as of now, that is the plan. The plan is to try launch tomorrow, in which case NASA television coverage will begin at 5 p.m. Eastern Time. So until then, we will sign off, and we'll join you tomorrow for the launch of DSCOVR on the Falcon 9 rocket. This is DSCOVR Launch Control.
Hi, I'm Peter Cullen, and you're watching NASA TV.